Hello everyone. Today in this session we are going to discuss about the input splits, and we have seen this topic input splits earlier from high level perspective. So now in this session we are going to delve deeper into the input splits. So let's see what is an input split. Input split is actually a logical. This is a logical representation. So this is a logical representation of the data which is stored on the file in file blocks. Because the data is actually stored in blocks in HDFS, that means it is a logical representation of the data stored in the file blocks. And you can say that this actually input split is a unit of work, which these 2 points we have already discussed in the earlier session. So this is a unit of work that contains a single, you can say, map task or single map task, right? Now the new things about input split which we are going to discuss more into the detail in this session is like actually it represents the data. This actually that represents data which is passed, or you can say which is uh, processed by the by an individual mapper. Okay, so till this point we have already discussed this. Actually this input split is passed to the mapper, and one input split is passed to the single mapper. We can also say that the number of input split is equal to the number of mapper we have. So now this input split actually doesn't contain your input data. It does not contain the actual data, or it does not contain the data. Instead of that, actually, or you can say input data or data, and but actually it is just, you can say it's just a reference to a data. The data is actually contained in itself in the block, but logically it represents the data stored in the block, so that it is just a reference to the data, not the actual input data. So we can understand this process like we have, let's say we have a split, and then split we have a records. So that means splits actually in records, which records are actually a key value pair, and this record is actually, you can say split is actually divided, rather I should say is divided into records, and then this record is processed in terms of mapper. So we can understand this completely in that way. Now actually the length of this particular input split is measured in bytes, right? That means the length of the input split is measured in byte because it contains the records. Okay, and then records are actually in reality or in physical world, it is stored into the blocks, HDFS blocks, say that. So now the actually what happened, the whole thing, if you remember the MapReduce flow, so we have an input split, and before input split we have the input format. So now input format actually it creates the input split. Input format create actually input split, and then after that what it do, it actually divide into the records. So that means one input split can contain many record also, right? You can understand in that way this input, this your file input format. So any file input format actually break into you can see 128 MB chunks, which was a default. I am just assuming that 128 is a default, but based on the new systems, and we need a more bigger size of the HDFS. That means 256, or sometime the default size are now set to the 512. But we are taking as a 120 as a default size of that. Now this information of the split size we can configure into the MapRed XML, and the property is like a MapRed. If you remember the last time we did MapRed dot, similarly we have a MapRed dot minimum dot split dot size, and this information is actually available in the configuration file called MapRed dot XML. So that means now we can change the size of the input split from 128 MB to depends upon what we need to fix it. Now next we can say that the number of splits or number of input split actually calculated for a particular application. So that means it actually determines this number of splits from for a particular application determines the you can say number of mapper tasks. So it actually determines the number of mapper tasks, right? So now I want to show you one diagram over there. Let's say we have a block size of 128. Okay, so now let's say we have two blocks called A and B. And just hypothetically I'm putting like a 128 MB, and this is also a 128 MB. These two is actually, you can say, this is a file stored in your HDFS as your data blocks. So this is a file stored in your actually a data block, and then this actually data blocks is, it can represent in logical form of the input split. So now let's say this is our input split, or it can be large or it can be big. So just I'm making this is my input split. Or rather I want just to on to add some more thing, like this information is actually our, just to make it more clear I'm just writing more, this is actually your data blocks, and this is our physical you can say HDFS, right? Now we have, this is our input split. Okay, this is actually one block A and one other block B of 128 MB, and this is, let's say this is our input split. What I'm doing is now input split is something like that, and let's say this one block I'm just making it a highlight color, but my data is till this point, and then another record is, so this is our input split first to understand. This is our input split, and this input split is our logical you can say logical map reduce, right? Now every individual, this part is actually one record. Okay, so now what happened, let's say our record is comes in between also, and this is one part of the input split. So now what happened, this actual file process, you can say this diagram will explain you that this is a files processed as input split, and actually which are composed of records. So this diagram is actually telling us the difference between the records and the input split. The very important point I want to highlight over is that if we use that, if using the starting record, now getting the information about the starting record in our block, and plus let's say we have an offset, and I'm calling as a byte offset. So what happened, we can get the information, that means we can get the complete record even if it spans to the block boundary. That means this record is going beyond, if you see this cursor, if even the record is going beyond the boundary of that, but if we have this information, let's say offset, and if we have the starting byte record information, we can get the complete record of this one. So that means now you can see that even one block, there is a one block A which is not completely covering under the record of the input split, still this information can be fetched, right? So this gives us a very high level idea, and I just want to add, that means this is actually your data block, and how this can be correlated with each other. So this diagram says the data input and the information about that. So now getting the basic understanding of the input split, I think this is the right time just to differentiate what is the difference between the input split and the HDFS block. Let's start the difference between the input split and the HDFS block. So just I am highlighting the input split, and on the other side I am just writing the HDFS block. So HDFS block, you have already aware about that it is a part of the integral part of the core component of the Hadoop ecosystem. You have studied about the HDFS architecture in the previous semester also. So now let's differentiate between the input split and the Hadoop HDFS block. So now input split is actually your logical representation of data, but on the other side, HDFS is your, just I'll use a different color so that you can easily distinguish. So HDFS is actually your physical representation of data. Okay, so this is very basic and common difference between this. And by default, in input split, this size is approximately equal to size of the block. We normally keep this as a default, but it can be configured. Okay, and I use the same, no problem. So that means it can be, we can configure. That means it is a, we can configure differently also. On the other hand, we can say the default size of the HDFS block is 128. Again, this is also configurable, but the size is different. On the third point, we can say that I can differentiate this as like, this is, let's say this is your one block, block one, and let's say this is your block two. But we can say that these are two different blocks, but our input split can be this one. So this green part can be your input split. So input split can be like, in a one input split we can have two blocks, or it can be possible that one input split can represent one block. Okay, so because it's a representation of logical representation of. Now on the other side, other hand, if we see this, so this is actually your block one, and this is your block two. So this is actually a HDFS block. There is nothing to do anything in that. And then you can say that this file is split in two different blocks. So these are the major differences. And if we add one more difference, we can say that input split, actually the number of map task, which we normally say that mapper, are equal to the number of splits. So this is the basic thing we have already discussed. And on the other side, if we say HDFS, that means this is the minimum amount of data. The HDFS block is the minimum amount of data that can be read or write. So you can say this is the smallest unit of data which can be read or write. Like this is a very high level difference between the HDFS and the you can say input split and HDFS block. So now let's understand few more internal details about the input split. So how the things happen into the as an input output in the particular MapReduce. Now let's focus with the new topic called like input IP. I am writing as an input and output in your MapReduce. So why I am using the input output in a MapReduce, so that we can at least see the role of input split in this process. And this process you already know that, but I am giving a different perspective of different perspective of a input output in a MapReduce from the context of input splits, right? So now just to draw the diagram, I'm just writing few important points. Let's, you know that what is, first we just create a, first we create an input split, or we can say I am creating creating a split. Okay, now after that we have a read split. I'm just keeping a gap, otherwise it will make a bigger rectangle or like bigger square. Now after that we have map. So let me draw the diagram so that after that we can discuss in detail. Now we have a map. Now we have a partition. Now after that we have a reduce, and after that we have a write out. So these are the different simple phases of the different MapReduce. So now just try to understand what actually happened into that. Now if you see the input phase, so just I am using a different marker just to show you the what is the input phase. So this is our actually a input phase. This is our input phase and this is our output phase. So I'm just writing as an input, I'm using a different color, and I'm writing as an output. So now we have, this is our different phase of a mapper. So this is our map phase, okay, and this is our reduce phase, because reduce phase definitely going to write the output of the reduce phase to the disk or some you can say some of the streams or disk or some other data store, data scene, right? So this is a different phases. Now you can see that in every stage something happens. So I mean to say that I'm using the different color again. So just I'm trying to grab the color uh, purple. So now just to create a split, we have an input format function. I'll just, so now we have just to create page, we have an input format dot get split. So this is the function. I'm just telling the on a very high level. So this function is used to create the split, right? So input format is the interface and it is having a split function. That means you can say input format class, we have a get split. It will create the split for that. So it means that this is connected. Definitely this is going to connect, and after that this is the flow of the data, right? Now for reading we have another function of record reader, because we have done all the different flow of the map reduce. So we have a record reader or a record, we have a record reader, and the record reader is having a function called next key value, right? So this function will give you the next split. So this will help you in understanding this one. Now in the mapper, in the mapper we have a function called like mapper is an interface, and mapper dot map is a function which is going to use in this phase. Similarly for partition, we have a partition class, and in partition we will call the get partition function, and this p is capital. So this get partition function, then it will give you the different partition. Just very important thing we have missed, just from the partition to the reducer we have from map to partition we have a key value pair, and from a partition to reducer we have again have the key value pair. So just I am writing this time k comma, and then instead of v I am just putting the list of v, because we will be having more than one word attached to the particular key. Okay, so just to understand this part, we have, let's say, word this. So now let's say we have a key and then we have a different number of lists. So that means this list will contain n number of is. So that means this will give you the this part, right? And into the reducer part, in the reducer we have again reducer interface. So reducer interface dot reduce is a function which is we are going to use into that. And in the end, if you see in the end, in the writer side we have a record writer class, and then we are going to use called function called write. So now if you see this diagram as an input output in MapReduce, you can see that just to create split we have a function called input format dot get split. Then after we read the split, for reading we have a record reader class and is having a next key value function. And similarly for mapper we have map function in the mapper class. For partition we have a get partition. For reducer we have a reduce function in the reducer class, and for writing output we have a record writer dot write function. Now just to get the important information, and I want to note it down, very important information from this diagram, and I want to sum up those information into the of this diagram, and I want to write it these point, and these points are very important, and you can say extract of from this diagram. Let's say first one. Now you can see that if you this create split, the create split is performed outside of the map phase. That means even the split process, splitting, when we say input split, these two part, creating and reading of input split, is separated into two different phases. That means create create split function is performed outside the map phase, and similarly you can see that read read split is performed as a part of map phase. Now you can see on the diagram also. And the last point I want to add, like this, all of the output. So all of the output is performed in reduce phase. This is the basic functionality of the MapReduce. Reduce phase, that means or writing your output, right? So this is the very important point I want to highlight. So this is all about the input and output phase. But if we see this diagram from different perspective, where in the application we have only a mapper phase, there is no reducer phase. So we will see in the next slide, next board. So just I want to show this same diagram from the perspective where there is no reducer. So let's move forward. So now let's see this diagram again. I'm using the blue one. So what we did is, first we created a split, then we read the split, right? And then after that we have a map, and when there is no reducer, that means we don't need to do partition. That means after map immediately we need to write output. So this understanding also you should be having when there is no reduce phase, how the things goes in MapReduce, right? So now the things are much similar. So I'll use a different color. Like say this is my now in this we have this input phase. This is my input phase. I'll make it a little bigger so that I can write more things over there. So this is my input phase, and this is my output phase, and my mapper phase is actually is a combination of these. This is my mapper phase. So this is my mapper phase. I'm just underlining all these phases. Now you can add all the functions which what we did, if you remember, just we have done just like for creating split, we have an input format dot get splits. This is the function, right? And for reading we have a function called record reader dot next key value, and for map function we have a mapper class dot map function, and for writing we have a record writer dot write function, and nothing more than that. So this is a basic, you can say, is the input and output in MapReduce. I'm just writing MapReduce and with no reducer or without reducer. This is a basic understanding. So now we have discussed the flow, we have discussed the difference between the input split and the HDFS blocks and basic understanding of input split. So we have discussed a lot of things about. So now let's focus more on the input format. And this is very important. I'm moving to the next slide so that you can understand in much better way. So what is actually the input format? So now let's understand the what is your input format, right? So now just to understand the input format, I'll just write the class name and some of the function just to have a better understanding. So now I can say this is your input format. This is my input format class which contains key and value pair, and this class is actually contains the two methods. I'm just using this part, right? The first method is very common, this is called a the method name is actually get split. What we did is get splits. So we will call it get splits, and this will give us the list of input split. What are the input split? So this is annotation, right? So you can assume that this function will return the list. That means n number of splits it will give. And we have another function is like a record reader, because we need a record reader. So this we have a record reader function. That means we need to create. We have a function called create record reader. So what this function will do, record reader. So this will create the record reader, and actually just I want to get into that it contains the input split as a parameter, so that it can create a record reader based on the key value pair, right? So it will create a record reader. So these are the two important functions which one should know about the input format. Okay, this is the class name. So now actually three important points I want to highlight into that. First, this input format is actually telling the type definition for the map input key and value. So it will giving in first information. I'm making as a 1. Another thing is 2. I'm making as a 2. This is actually partition the input data. This is my input data. The partition the input data into input split, right? So this function is actually partitioning the data into the partition means here dividing the data, segregating the data. And third is this one. So this is actually creating or is create a record reader to read data from your job, right? Job inputs. So this thing is actually will clear the what is actually input format class and 3 of its contract within this class. So we can also nomenclature this diagram. That means this is the input format class and its contract. The contracts are actually what is there just to do what are the things needed to be done by the input format class. Similarly, on the other end, you can also see the output format class. So let's see the output format. So we have an output format. In output format, we have again we have a key value, right? So this is a key value. First function is like record record. Just the function we have a record reader. So here we have a record writer. Okay, so this will get the get record writer, and then this will give the record writer on the key and value. And another function is actually a little important. The another function is your check output specification, and this specification is actually about the validating the things. I'll just come to that point. And the last point is get uh, output committer. Okay, this is another function, and this will give you the output committer object, right? So this will give you the output committer object. So these are the 3 points, 3 functions in the output format. So just I want to again using the same I just want to add this. So this is actually type definition for reducer, because output format is on the reducer side. So this is a reducer output, that means reduce output key and value. Now second is what it is doing is it is actually creating a record writer instance, and that will help to write the data, that will help to write the data. Third is about the validating. That means here we are verifying the output details associated with the MR jobs, right? This is the some kind of sanity check, you can say, MR jobs, and that means they just checking that these are correct or not, right? This is a sanity check on that. And last but not the least is the fourth one. Fourth one is actually what it is doing is it is actually getting the associated output committer, which will help us to write the data to the data sync, right? So this is output committer. So now what is the you can say role of the output committer? Actually it is responsible for finalizing the output after the successful, you can say, task or job completion, right? So now you can see that we have discussed about the input format also in little detail, and what are the different function of the input format, like splitting, get split just to get the number of splits or all the splits in a list. And we have a create recorder, okay, the create record reader. Similarly on this other side, input format has a get record writers, and similarly some output committer and some validation check. So this is actually about the output format class. So that's all about the today's sessions. Thank you for attending this session. Thank you very much.